Good morning, everybody. How are you all doing? I'm just curious, how many folks are at your very first Google Cloud Next? Excellent. Thank you all. Can we give them a hand? Yeah. Excellent, excellent. Thank you for coming out. My name is Bobby, and as you can see, this is not Calc 101. This is Automating Excellence with Gemini and KCC. And so if you're here, you're in the right place. But we want to really just thank you for giving us some of your time. We want to make this session and this week hopefully a great use of your time. You're going to learn all the things, conquer world hunger, global warming when you get back, all because of what you learned in this session, right? And so I'm going to be one of three speakers you're going to see. You'll see from the pictures and from real life. I spend a little bit less time in hair and makeup than those guys do, but I'm going to get out of your hair in a few minutes. And then they're going to come up, two very capable speakers that'll kind of help land the concept of what we want to talk about today. So this is going to be our agenda. I do walk around a little bit. I hope that doesn't make you all nervous. Makes it harder for you all to throw stuff at me if you don't like what I'm talking about. But I want to land 2 points. We want to talk about the 10X Cloud Team Vision. Michael's going to come up with the great picture insights from CME Group and how they're using KCC to infuse that into their DevOps practices. And then Eddie's going to do a demo and bring some content around agentic compliance. Does that work? We good to go? All right, so what is KCC and why it matters? I'm just curious, how many people here don't know a whole lot about KCC and are curious to learn more? Excellent, excellent. So I'm going to start at a higher level and then we're going to go deeper as the session goes. So what is Config Connector? So simply put, KCC stands for Kubernetes Config Connector. It's an open source Kubernetes add-on that lets you manage your Google Cloud resources. Think things like spanner databases, pub subtopics, storage buckets, like Kubernetes configurations. And so if you know how to write YAML for deployment, you can use that to manage all of your Google Cloud resources. That makes sense? You're already experts, right? You're on your way. And so that talks about what it is, but not why it matters. And so for why it matters, I want to go to TV for a second. Who here has seen Shark Tank, right? Okay, so for those who don't know, executive summary, for those who haven't seen, Shark Tank is where you are trying to have this ultimate pressure test, right? These entrepreneurs walk down this long hallway and they pitch to people like you all self-made billionaires, right? You'll be self-made billionaires for this part of the talk. And so they come and they pitch their ideas, and these sharks are trying to partner with these entrepreneurs because they're looking for a few things. So one is a pressure test if the idea is valid. Number two, they want to understand, does this product or service solve a persistent problem in a way that's scalable and durable? And then ultimately, is it going to provide a massive return on their time? Everybody with me? And so at a conference like this, you're going to see all sorts of things where people talk about stuff and where we give you ideas for things, right? And so where I want to go now, if you look at some of the successful pitches that have happened, Bomba Socks, almost wore some of those today, Ring doorbells. Anybody tried any of the things that are on here? Yeah, it's okay, excellent. I don't think I've done the Tipsy Elves thing. Those are the ugly sweaters, right? I don't think I've done that one. I think I've done everything else on this list. But that's not actually what I want to talk to you all about. What I want to talk to you about is one of the most successful products in the history of Shark Tank. Who's seen that little smiley face sponge thingy? What is that called? The Sponge Daddy. I want to talk about the Sponge Daddy, okay? Here's why I want to talk about the Sponge Daddy. I want to talk about that because I think that this has very analogous application to KCC and Kubernetes. You're probably like, Bobby, where in the world are you going with this? Hang with me for just a minute and I'll get you there. So here's what happens. At a conference like this, you're going to hear lots of opinions around things, like how to do things and all that. We're not here to tell you that you've been doing it wrong. We're just here to tell you there may be a different way. Now, in contrast to that, I've been married for 26 years, and my wife doesn't say there's a better way. She said, you're doing it wrong. And so one of the things that I was doing wrong in my house when it was time to clean dirty stuff, I would use the Scrub Daddy, and then when I couldn't get it clean, I would throw it away. And these magical words from my wife transformed my life. She said, you know you can just put that in the dishwasher, right? Who didn't know that? Come on, be honest. Don't leave me out here by myself. You can, and it's literally in the FAQ on the website. You can put the Scrub Daddy in the, and I was like, what? Are you serious? Listen, after that, I was like a superhero unleashed against the evil forces of dirt. I felt like Green Lantern with the Sponge Daddy in my pocket. I could conquer anything. Now here's the issue. I had the Scrub Daddy in my hand, but I had the old school sponge on my mind, right? I didn't have the right mindset. So why is this an issue? Here's the statement. The dishwasher is to the Scrub Daddy as KCC is the GK. This is 1 and 2 points I want to land today. Are you with me? So how does this work? KCC is not just a deployment tool, it's the restoration system. All right, how does this work? dirt is a persistent problem, right? At least it is in my house, right? If you have kids or pets or anything like that, dirt is a persistent thing. Is configuration drift a persistent thing in anybody's environments? Do developers change things? Do architects deviate from standards? Anybody with me? If those things happen, then you can relate to the persistence of dirt, right? And so the systematic solution is not just having a sponge, but it's having a way to clean your environments in a way that you don't have to throw it away, right? And so that's why I think this is very Scrub Daddy-like. Now, is a Scrub Daddy a product or a system? Yes, it's actually both, right? Because if you look at the expansion of the Scrub Daddy, it might have started off in the kitchen, but it's expanded to other rooms in your house. I use it for my grill. I use it in the kitchen. I use it in the bathroom. But the point is, three things, right? It goes from throwing things away to being able to restore stuff. It's got different states that it can take. Again, if you look, reading is fundamental. If you look on the website, it'll tell you all sorts of cool things about the Scrub Daddy, different temperatures and all that kind of stuff. But the point is, it can adapt to your environment. And the reality is, it's a system to restore from configuration drift. And so the mindset, the same way the Scrub Daddy is expanded to different parts of our house, we believe KCC can expand to different parts of your environment, right? You might start off using it to reconcile storage, but then you can use it for networking or security or databases. It's a system to get things clean again and to get them restored. And so the reconciliation loop, if I could put this on a t-shirt and get paid for it, it would be, is your infrastructure strategy top rack dishwasher safe? Do you have a plan to restore things that doesn't involve throwing resources away, right? Because KCC, again, reconciles things back to the original definitions of those clean expectations. So here's the comparative anatomy, right? We have an initial state, the Scrub Daddy, for those who came, again, you're like, wait, the Scrub Daddy, KCC Kubernetes, this doesn't make sense. Stay with me, it's okay. So look, you have this initial state that's very clean and pristine and ideal. Things get dirty. Pets, kids, architects, developers, same thing, right? You got a top rack dishwasher or a reconciliation loop in KCC, and in the end, you have a like new condition or a self-healing infrastructure. Now, what's the point? Back to the title. In this agentic age, for us to be 10x cloud teams, we have to embrace 100% auto healing and zero manual toil. Other than that, we're not going to make it, right? Because we got to do more with less. And so the quote, similar to, again, not like my wife who tells me I'm doing it wrong, we're not reinventing cloud, we're just telling you there may be a more resilient way to manage it, right? So again, 2 points. Who remembers the first point? The dishwasher to the Scrub Daddy is KCC is the GKA. We got it now? The light bulb's on, okay. Now one more meta point, as you're gonna hear AI lots of different times at this conference, okay? Before I get off and hand it off to Michael, I gotta give you my executive summary for AI. You ready? Okay, here it is. AI is not the thing. AI is the thing that makes the thing better. So if this were food, AI is not the dish, it's the sauce or the spice that makes the dish better. And so why a lot of people are mad right now is because they're putting good sauces on a plate and calling that a meal. It's a taste, but it's no substance, and it leaves people wanting. The foundation is Kubernetes. The extension is KCC. The additional flavor you're going to get today from Michael and Eddie is going to be AI, but it's not the only thing that matters. We're kind of building this up in the right order, okay? All right, Michael.
My name is Michael Ciacco. I'm a senior staff platform engineer at CME Group. We've been there about 7.5 years. And I know there's going to be people in this room that have never heard of CME before. Just know that it stands for the Chicago Mercantile Exchange. And I'll give you guys one guess where I'm from. Detroit. So, but I live in Chicago. All right, so I'm excited to be here today to talk about KCC. It's been a real game changer on how we deploy infrastructure. I'm going to talk about how we did it and how it will be helpful for your organization. We'll go through why we chose KCC, how it was rolled out, and what some of its gotchas and limitations are. So let's get started. All right, so for almost 200 years, CME Group has been where the world comes to manage risk. And in our world today, managing risk is more important than ever. We operate the world's leading derivatives marketplace. It's where people can trade on options and futures. And in 2025, our clearing system saw $1.5 trillion settled through our systems. That's 6.7 billion a day on the days we were open. And during extreme market volatility, we saw $32 billion. And coincidentally, one of those days was last year at Google Next. So if you saw somebody in the corner rapidly trying to spin up resources with KCC, that was me. That happened. So we've had a lot of innovations over this time. But if you notice, 2019 is missing. That's the year I started. To me, that's the most innovative thing CME has ever done. So while I'll have to talk to somebody about updating the slide, we can focus on 2021. And that's the year we entered into a partnership with Google. And it's what started us on our path towards using KCC. So our history is long and storied. It's all up here. If you have any questions, I'll be around after the presentation to chat. All right, so before talking about KCC, I'd like to set some context on our environment. We currently manage around 230,000 Google resources using Kubernetes Config Connector. That's across 2,200 projects and with about 1,500 users. That's on our application teams, our SREs, platform engineers, security. You name it, if you're in technology at CME Group, you use Kubernetes Config Connector. And so in the last slide, I talked about how we entered into a partnership in 2021 with Google. And this was unique because it came down from the top. Our CEO and the board had an idea, and it kind of triggered this mandate for an accelerated cloud migration. A lot of people wanted us to get there and get there as quick as possible. And that was a real catalyst for change. As a platform engineer, we had an opportunity to redefine engineering culture. So before Google, we were in AWS. We had a smaller footprint, and we used Terraform. We knew Terraform, and that was going to be our plan. But I met Eddie in early 2022, and he said, hey, you should look at KCC. And so we did, and we saw what we liked. But we knew it didn't solve everything. So for us, we use a layered infrastructure strategy where we lay down the foundation with Terraform. That's projects, organizational IAM, networking. It's only when we move left that we start using KCC. The application teams use it, and it's a simplified developer experience. It eliminates the need for teams to learn both Terraform and YAML and Kubernetes. So it's a unified language. We manage if you want, you can manage all your infrastructure through the same Kubernetes interface as your applications. So at CME Group, if you want, you can YAML all the things. Treat every cloud component as a native Kubernetes resource. All right, so one of the things I love about KCC is that it's GitOps native. You can have a GitOps controller like Argo CD, Flux, or even Google's config sync, and it'll automatically detect config drift on the Kubernetes cluster. You set your source of truth in a Git repository, and it synchronizes. So if a resource changes on the cluster, the GitOps controller will change it back. Similarly, Kubernetes Config Connector runs and does the same thing in the cloud. If a resource changes in GCP, whether through the UI, G-Cloud, or some other automation, KCC will pick up on it and change it back. There's also a reduced deployment tax. It eliminates the need to build and maintain complex Terraform pipelines. Infrastructure is no longer a job to run, it's a resource to declare. GitOps gives teams self-service autonomy. They don't have to wait on external dependencies to create the resources for them. No more Jira tickets, no more work orders. And at CME Group, we saw quick adoption. Teams embraced KCC because it mirrored existing deployment patterns. The developer lifecycle transformed infrastructure from a specialized bottleneck into an automated workflow. And if deploying infrastructure through a Git repository is called infrastructure as code, deploying policies the same way is called policy as code. And now, so security is now part of the same GitOps lifecycle as applications. You have objective enforcement. Automated pass-fails have replaced manual security reviews. And it gives you compliance at the source. It's mandatory encryption, no public endpoints, and even operational policies like cost center labeling. And what it does is it acts as like a two-tiered admission control. First, it shifts left and puts these OPA policies or Kyverno policies into your CI pipeline or your continuous integration pipeline. If a pull request is created, it's validated against those policies, and if it violates those policies, the PR is marked as needs work, and the engineer has to go back and fix it. But let's say for some reason there's a false negative, or even somebody does something manually on the cluster. You can have a policy agent running on the cluster, and that acts as the final safety net that blocks these resources from being deployed, or similarly, if somebody does something manually, it will also be blocked. And we also use this isolation by design. Principle of least privilege is only granting identities the access that they need. So what we do is we scope KCC controllers down to the namespace, and we only grant the service accounts running those controllers the access to the projects they need, so teams do not deploy resources and projects they do not own. So rolling KCC out, the first thing you'll notice is that you have to solve the chicken and the egg problem. No matter how much we want it to, KCC cannot deploy itself. So we have to do that first. And for us, that's where that layered infrastructure strategy that I spoke of before works. We deploy the foundation that KCC runs on using Terraform. It's only after that that we start using it. And to architect for scale, when you're rolling out KCC, your organization is going to look different in 2 years and 5 years. So you have to think about that and what the scale is going to be. Make sure to align KCC service accounts with the GCP organizational hierarchy. Projects exist in folders. With KCC, you're inevitably going to have a root service account that's going to talk to all the projects. Permission that at a folder level so that it propagates down to all the projects underneath. And then, as I said, we scope down to namespaces. Those service accounts are scoped specifically at the projects. And we actually have a one-to-one-to-one mapping. We don't just scope Kubernetes namespaces to projects. We also scope Git repos to projects. By giving teams a dedicated Git repository, we move beyond the monorepo, and this prevents CI/CD bottlenecks. It's also important to build in a promotion path, right? When you build these pipelines, teams are going to be moving YAMLs from dev to production. And inevitably, there's going to be common configurations, but they'll be different, right? Each project will have a similar configuration in dev, but it'll change in QA, and it'll change in UAT and prod. Make sure to build in automation that mutates these configs so that teams don't have to do it themselves. And as you're building out your infrastructure, you're paving that road, and you want to make sure the road is pointed in the right direction. So provide a supported path and pilot with early adopters. You want to stress test your workflows. Make sure that it works before an organizational rollout. Okay, so transitioning from ticket ops to Git ops, that's a huge paradigm shift. You're teaching people how to use KCC. You may be teaching them infrastructure as code, Kubernetes. There's a lot to learn. So for us, we had workshops at our different offices. We created these self-paced lessons that we called katas so that teams can do it over and over again until it was second nature. And we even had a cloud experience team. And this team was at the front lines. They triaged support requests. They curated a knowledge base in our wiki. And they even reviewed and merged pull requests, or reviewed and approved pull requests. Our CI pipeline merged them. And it's also important to onboard at velocity. As soon as those floodgates are open, everybody's going to want their project, their KCC namespace, and their Git repo, and you don't want to be doing that manually. For us, that was an Argo workflow. Teams could log in, initiate the workflow, input a bunch of parameters. We had drop-down lists and input text validation to make sure that what they input matched our standards. And then create reusable abstractions. Bundle complex GCP resources into templatized YAML. Don't have teams reinvent the wheel, create a golden path. For us, that was Helm packages and a little bit of KEP packaging. More recently than when we started in 2022, there's Crow Resource Graphs or Kubernetes Resource Orchestrator. Just do something that helps your teams move quickly. And then your paved road is going to be battle tested. Use the early friction and edge cases to move your platform from beta to production grade. Convert common support hurdles into automated guardrails and hardened infrastructure. All right, now's the fun part. Real-world scars and gotchas. We've stubbed our toe along the way. We've skinned our knees. Hopefully, our pain is your gain. The first thing is resource deletion and protection. So when you deploy something to KCC, it's going to create or update it in the cloud. But if you delete something with KCC, it's also going to delete it. And if you delete a namespace in KCC, it'll delete all the resources underneath. Use KCC's abandon annotation to orphan the resources in the cloud. Think of things that store data, like storage buckets or SQL instances, things that are used a lot, like Kubernetes clusters, and interestingly, IAM service accounts. These guys have a unique ID. The IAM policies that back that cache the ID. And while a service account can be deleted and recreated very quickly, the policy that backs it is going to be invalidated. All right, next, controller tugs of war, or what I like to call reconciliation fights. You're going to have a GitOps controller deploying your desired state, which is in a Git repo, to the cluster. When that happens, KCC is going to pick up on it and make that same action in GCP. GCP it will send a response on whether it's successful or not, but there may be other stuff that the controller parses. And it usually doesn't, but sometimes it will update the resource on the cluster. If that field is managed by your GitOps controller, the GitOps controller is going to overwrite it if it's different, and the cycle will start all over again. The only way to break that is to update your GitOps controller with the desired state of KCC. KCC always wins. Next, immutability. This is not just a KCC issue. Kubernetes protects against changing certain fields in stateful sets and jobs. And Google resources have some fields that can only be written on create. The most common areas where we see this is with IAM policy members and BigQuery table schemas. When somebody updates it, if it's manual, it's just going to fail that one time. But if it's in a GitOps controller, it's going to continually try to update it. And those updates are going to fail. And the GitOps controller may go into an exponential backoff, but it's going to report a broken state. The only fix is to delete and recreate the resource, or revert the change back. But there's a hack, right? And I'll tell you about it, but you have to be careful. You can use some of these resources actually are mutable, the fields. You can do it through the UI or G-Cloud. If you can, it's not all of it, but if you can use the abandon annotation that I spoke about before, create a pull request to add the abandon annotation, and then very importantly, validate that annotation is there. Once that's done, create a second PR to delete the resource from KCC. It's now orphaned in the cloud. And then you can do, either through the UI or G-Cloud, you can update that resource. And then you create a third pull request that removes the abandoned annotation and updates the field, and then KCC will reacquire ownership. Okay, so this is my last slide. There's an IAM policy limit on all Google projects of 1,500 members. That's cumulative over all the roles and all the members added together. If your project gets too popular, and for us that first happened with our artifact registry, and then again with a cloud storage bucket, you're going to hit this limit, and you won't be able to add any more members, onboard anything else. The fix is to leverage Google groups. Add users and service accounts, or you can even add other groups to a Google group. There's also something called principal identifiers, and more specifically for Kubernetes, principal sets. With that, you can wildcard all the Kubernetes service accounts in a single namespace, or all the service accounts in the entire cluster, or even in the entire project. And wildcarding will also help you get below the limit. The next one is project quotas. And if you're in Google, you've probably run into this. Well, KCC makes API calls. Those API calls go against a quota. What'll happen is you'll get a 429 quota exceeded error, and KCC will no longer be able to manage what it's trying to manage. The fix is to distribute these API calls. Each controller is deployed via a config connector context. In that context, you define the service account. You also define, well, you don't define it, but you can override it, where the API calls go. And you could say, go to the target project of the resource. As long as the service account it's running as has service usage IAM on that destination project, the API usage will shift to that project. And the last thing I'll talk about is policy overload. KCC has hundreds of resources, and they're adding more every week. It's very easy to overdo it with security policies. Think of IAM policies. Think of how many roles there are out there. It's limitless. And if you overload your policy controller, for us in KCC, that's Gatekeeper, it'll start to time out. And when it times out, your deployments are going to come to a standstill. And we saw it take hours to deploy a single resource or even update a resource. And the fix is to make sure Gatekeeper has enough resources to run. Use a vertical pod autoscaler and make sure it's highly available, multiple replicas, and a pod disruption budget. All right, that's my time. KCC has been a real positive for CME Group. I know it can be a positive for your organization as well. I'm going to hand things over to Eddie, who has some exciting things to say about how AI can augment KCC managed infrastructure. Thank you.
Thanks, Mike. I appreciate it.
Yeah,
thank you.
Thank you.
All right, big hand for Mike. When I reached out to Michael, he gives me credit for bringing in KCC. I got to be careful if I want that credit or not. But two, I joined Google about 5.5 years ago, and when I came into Google, about 5 or 6 months after onboarding, I get a call and they tell me, hey, I need you to work on a project. It's a very important account. I can't tell you the name of the account. I can't tell you what they do, and you can't talk about it to your own boss. I'm like, what? And I had to sign an internal NDA, and come to find out, it was CME Group, and I worked to actually bring CME into Google Cloud, and so I've been in since the beginning of our Google Cloud journey and our partnership. And I think it's been an amazing partnership. So thank you, CME Group, and I've been really happy just seeing the progress to really bring cloud native platform engineering to fruition. And imagine an organization as storied as the CME Group, 200-year-old organization. You talk about there's some skeletons in closets and other things that are hiding out there and legacy things. And then the bravery to say, I want to go to cloud and accelerate. And as Mike said, this was a way to help push that and accelerate that as fast as possible. And I've been tracking the acceleration. Well, also, when I talked to Michael about doing this talk, he said, well, I'm going to talk about all the things that we did. I'm like, great. And I go, talk about the bad things. Right? I want it to be honest. I want the reason to have a customer like CME Group in front of customers like yourself is so that we don't build perfect things. We know that. We try to build really good things, but they have problems. So I wanted him to be very open with one of the issues that are happening. And then what that brought to me was this idea. It's like, well, let's look at how we can take KCC and this new world of AI and agentic skills, and how do we solve some of the problems that Mike experienced during this kind of learning phase to get KCC going up and going. So as Bobby mentioned, AI is the seasoning, right? It's what makes things better, right? And in this case, AI, go back to the Scrub Daddy, right? The Scrub Daddy, you have to go and put it in the dishwasher. You have to do the scrubbing and all this other stuff. I'm going to say agentic skills in AI now becomes, your Rosie the robot from the Jetsons, for those of you who are old enough to know what the Jetsons are, but your robot housekeeper, right? Using that Scrub Daddy for you and helping you. So how can I take agentic skills and bring those things that Mike had to kind of hack and find and cheat, get all the cheat codes, and now make it shift left so you as a platform engineer can now use an agent to help you overcome some of these things very quickly. So we're going to show you that. So what's an agent skill? Anthropic, great partners of ours, Anthropic released this protocol for something called agentic skills. Very simply, it's a directory-based structure for large language models and IDEs or CLIs or other LLM-based tools to be able to have a structure to extend the AI's capabilities, LLM's capabilities, into a more structured format. And in the case of an agent skill, there's a directory. That directory has subdirectories that have certain information. We'll get that in a minute. It has on-demand context. So as you ask it to do something, it's actually reading this, and it's a very simple markdown. If the most basic skill is just a markdown file. Skills.md, we'll see in a minute. But it's also action-oriented. You can actually have a folder called scripts, a folder called resources, and that scripts folder can actually have scripts, files, binaries that the agent is aware that it has access to and is able to use to make your life easier as an administrator. But more importantly, when you're using something like an IDE, and I'll show you, we're going to use anti-gravity. For those of you who never heard, how many of you have heard of anti-gravity? Okay, good, right. So anti-gravity, it's very similar to like a Visual Studio Code. It's our IDE, our agent forward or our agent-based IDE. And so I'll show you the skill in anti-gravity. But basically, you have this .agents folder, and then you have skills, right? So it runs locally. This is now part of your workspace. You can also install a global skill. So there are certain skills you want access in every directory you're working on. But basically, the only file that's needed is that skills.md file. And that file, you just really write a good descriptive information or context for that agent to understand what is its job, what is it doing, right? And then there's a mandatory description field that acts as that trigger phrase. So as soon as I prompt the agent with something like, hey, I want to do something on KCC, it knows like I need to use this skill and all of the resources around that skill at this point. And it starts to auto-activate the skill. We'll see that in a second. Now, the cool thing is really the steps that actually happens. First is discovery. It reads the data, minimal metadata, like the trigger description, and it evaluates if this skill is relevant to what you're trying to do. Once it has that, it starts to activate and then bring all the context in, right? So it reads the whole markdown file, applies any special rules, the parameters of the skill, and then it binds that kind of LLM to understand, like, this is what I'm doing, these are my constructs, my guardrails, and this is what I have at my disposal to use to help this person move forward, right? And then finally, the execution. The agent follows that documented workflow and invokes any scripts or any of the other things that it may do, external tool calling, whatever is necessary that you bundle into your. So now let's see it happen live, right? Oh, this is scary. You know, anytime I do an LLM live, I'm scared. So let's go to demo time. So here's my anti-gravity, and great, it's out of date already. I got to update it. That's okay. I'm just in a regular directory, and I'm kind of playing around with some YAML files for KCC. So I'm a KCC operator, Mike's assistant, henchman, and in this case, I have a restricted bucket YAML definition. And here I have an IAM policy member definition. I also have a storage bucket definition. Now you'll notice, as Mike said, I do have the project ID, and I also have my deletion policy, that abandon annotation as well, right? So again, some good practices, things like that. And then I have a region, the storage class, some lifecycle rules. These are just all parts of the CRD that make KCC understand how do I describe in YAML what GCP wants to create this object in Google Cloud, right? So think of it as just a YAML definition for an object for the Google API, right? Now, you'll notice on the right-hand side, I asked first, Mike just hired me. I'm a brand new junior dev, junior engineer, platform engineer. And I said, look, I'd like to check if the config connector environment is healthy and give me a summary of any KCC resources registered to my cluster. So immediately, it went out, it knew my context. It said, the cluster I see is GKE BRK2111, that's this session. And the namespace is default. My GCP project is BRK2111 demo, and my account. So I said, yes, do I want to proceed? So we'll go ahead and tell it to proceed. So this is one of those things where people feel like, hey, agent, out of control, human in the loop. It's asking me questions. Like I can tell it to move on or not, right? To go do things, okay? And then it's also telling you everything it's doing, what it's calling, what it's doing. It's telling you its thinking process. So you can actually go through and see what is it doing, how is it thinking it. So it analyzed the KCC, it analyzed based on that prompt that it's going to use this KCC ops skill, and it's going to prioritize, and it's going to ask me, hey, I need to run a script. Are you allowing me to do that, right? Again, human in the loop. We're not doing the agent just, run amok. You could if you want to. In anti-gravity, you can just say, hey, yeah, go ahead and just don't bother me anymore, right? Now, it'll go out, do some stuff. It'll come back and give me a good error report. I'm running Starship. Don't worry about it. But anyway, that's why I'm getting some of these errors. But it'll come back in a minute. Again, so it prompted me from the command, says, yes, I want to go ahead through, and we'll go through, and it's gonna continue going through, running its context, and make sure that it has all of the information to give me back a report, what they call basically a work in anti-gravity. Basically, it's like this is the output, and it's just going to give you a markdown file with all the output, right? So now I'm doing inventory. I do have this recorded. I might move to the recording so just a little bit faster, but I did want to show you how anti-gravity is not just running amok and doing things without me knowing. It is actually asking me to do things to make sure that it's not just do I need to put Y here? Accept. Okay. There we go. So now going through, it's verifying the namespace. It's also verifying that it's ready, and it's going to get all of the information, come back with an output. Can we switch to the video when you get a chance, just so I can go through the rest of it much quicker? Down to 8 minutes, exactly the length of my video. Yeah. There we go. Okay, so here's my output. It gave me a well-formatted output. I have the run health check inventory scripts as per KCC ops skill. It came back. It does see the namespace. It's also registered all of the different KCC objects that are registered to that system as well. And again, what region, what the information is, and then everything looks to be up and running and working smoothly, right? So if I go now and look at the actual skill, what I've actually done is I've taken a lot of Mike's problems with KCC and I've just integrated them into the skill. So I will tell it, like, look for immutable fields. And if I'm about to change an immutable field, let me know first. So that way I never have to worry about going through and pushing in a field by accident that's immutable and causing that error, right? So as an example, I can also say, let's look through my history here of my past chats. Yeah, go. So another one that Mike talked about was verify your, vet out a YAML against policy. So I tell it, hey, I have a policy directory from Git. I want you to go and use like Gator or use Conftest to go and then check my YAML and compare it to policy. So I will know if my YAML is policy compliant before I even submit it to my GitOps, right, and fail. Shift left. So as this platform engineer, this agent is helping me understand, hey, by the way, you have public access prevention is not set. It's going against best practices, you probably should. There's access control issues as well as a violation, and it's also giving you a detailed analysis of what it would do, and potentially also how to harden the YAML file based upon all that information, right? I've also programmed into this KCC ops to also always check live the GitHub repo for the CRD manifest for every CRD in KCC. So that as I'm writing, I can always vet this against the CRD to make sure that I have all the proper things. So now, Mike talked about he had to get people to learn and had all these lessons and katas to help people understand how to use KCC. Now I just get the agent and say, hey, what fields are available for me to create a storage object or to create a BigQuery table or to create a MySQL table in Google Cloud? And it's going to go against the current KCC repo, verify, and then come back and help you format it, or we'll write the YAML for you, right? And then check it against compliance and policy, and then you can go ahead and now submit it through your normal GitOps process because now you're in your IDE. So now you haven't broken the flow, but you're shifting left. A lot of the problems, things that Mike experienced and the CME group experienced while they were trying to go through this in production, now we can bring this faster and the agent is there to help you move forward a lot quicker from there, right? So what's cool about this is, can we go back to the slides? I wrote a code lab. You can build this demo, this KCC ops skill yourself. Okay, so the code lab is not 100% what I have. I'm hoping that we will have a full-fledged KCC ops skill in a Google Cloud Platform GitHub repository within a month or two. We have to go through security review and a lot of vetting. But I walked through the same exact process that I used to build in anti-gravity, this skill. And I included the markdown, I included some of the inventory scripts, the health check script, the policy check script. So you can actually create your own KCC ops skill and hopefully maybe make it better, right? And make it like fit your organization or your needs. And you see how easy it is to really write these. And before you know it, you're gonna write a bunch of agents skills just to help you make your job easier. That's how easy it is to write these. And it is actually a skill that you can get for anti-gravity on building skills for anti-gravity. So it's like a very meta, like I can skill to build skills. But yeah, you can do that. So that is a code lab, and you get some free credits on GCP if you to try that as well. And also, I am not the product manager for KCC, but I love it. I go back way back. Frank Curry is the current product manager for KCC. We created a Google form. If you want to talk to Frank and the team, the engineering team, and you want to know more, you want to give feedback. We do have another session in a bit called the discussion group on KCC that one of our customers, Spotify, is leading. I will be kind of just managing the session. But it's a very small room, so some of you probably couldn't get it. It's already booked. It's already sold out. But this way, we can get Frank and the team to reach out to you directly and make sure that we get all of your answers taken care of from there, right? So as you see, there's a discussion group. Hopefully you already registered for that session. Other sessions that are kind of ancillary, BRK1061, Google MCP. This is another connect. Accelerate your CI/CD with other agents, and also anti-gravity. And then the big one, which is what's the next decade look like for GKE? And that's Drew Bradstock, our principal, and Gary Singh, one of my peers, and then also AI DevOps Velocity, right? Platform engineering with Google Cloud. And obviously, we really want your feedback. This is how we make our sessions better. I'll be around. We have to get it for the next speaker. We'll be hanging out. We'll go over out there. If you have any questions, come up, talk to us. Thank you all. Appreciate it.